Hello, everyone. Um, Today, we're going to go over ketones and aldehydes, which is chapter 18. This should be the first chapter that you guys have uh, gone over after exam one. Now, normally in previous semesters, this material is in the third unit, but it looks like they are switching the third and the second unit this semester. Not sure if it's because of virtual setting or because of the snowstorm, but uh, regardless of what the reason is, I will cover the material that you guys are going over in lecture currently, and that happens to be chapter 18, which is the aldehydes and ketones unit. And just to quickly brief the second unit of this semester. Since you guys just took your first exam, I hope everyone did well. I hope these reviews are helpful for you guys. Please let me know. Feel free to email me or let me know in the comments or come to the live reviews Mondays at 4. If you guys have any questions and want to ask me directly, so that I can help you get the best results. So last unit had a lot of conceptual puzzle pieces, a little bit of reactions. This unit, more so than the final unit, will have majority of the reactions you will learn for the rest of OCHEM. And we're going to start off with aldehydes and ketones. Next week, we'll probably talk about enols and enolates, after spring break, rather. And then we'll get into carboxylic acids and their derivatives. And then we'll have exam number 2. And then after exam number 2, we'll be discussing conjugated pi systems and molecular orbitals, aromatic compounds and their reactions to finish us off before the final exam. You still have 3 more quizzes as far as I'm aware. And yeah, so obviously, since next week is spring break, there will not be a weekly review. Our last day of peer tutoring, or we're closed from this Saturday until the Monday we open up. That Monday is when we are back for virtual peer tutoring. So yeah. All right, so I'll get started with this week's lesson. All right, so once again, chapter 18, aldehydes and ketones. Now, there's a lot of information to unravel in this video, so please make sure you understand all the reactions and understand every little bit of extra information I give you. All right, so you should have some previous knowledge on some of these reactions and concepts, and especially the reagents. But when we talk about aldehydes and ketones, we're going to start off by talking about oxidation of alcohols and cleavages of double bonds. So let me write something down. So again, first we're going to talk about oxidation of alcohols. And within this, we're going to talk about 2 specific types of alcohols. We're going to talk about primary OHs, and then we'll also talk about secondary OHs. Okay. And then I'll draw what that should look like. Primary alcohols look like this. the OH is only bonded to one other carbon. And then secondary alcohols are bonded to 2 carbons. Or 2 other carbons, rather. Okay? And then within these, another subcategory of each, I'm going to go over what happens if a strong oxidizing agent reacts with it for both. Okay? And then what will happen if a weak/mild oxidizing agent reacts with it, and for both. Okay. So within these, before we, see how the reaction occurs, we have to identify all of our weak oxidizing agents. Okay. So first one is going to be sodium chromate. So Na2Cr2O7 is the first one. You can also have chromium or chromic acid, which is CrO3, or you can have KMNO4, one that you should be very familiar with. Okay, likewise, I'm going to copy it down here. Make sure you're committing these reactions and reagents to memory to make sure you know which goes with what. And then now we'll discuss the weak oxidizing agents, which is PCC, PDC, BMSO/SWERN. Yeah, that should be it. PCC, PDC, BMSO/SWERN. Okay. So when we have a primary alcohol and we are reacted with a strong oxidizing agent, it should look like this. We'll turn it into an aldehyde. Sorry, a carboxylic acid. Okay, and then I'm going to do the secondary one as well. When we have a secondary alcohol and a strong oxidizing agent, we should get a ketone. Okay. Now back to primary. If we have a primary oxidizing agent and we have primary alcohol and a weak oxidizing agent, we should get an aldehyde instead of a carboxylic acid. And the reason why we don't get a carboxylic acid is because our reagents are not as strong of oxidizing compounds as the stronger ones. And then for secondary alcohol, if we have a weak oxidizing agent, we are going to have a ketone. So if you notice, there's only a difference in the primary alcohols and not the secondary alcohols, because regardless of weak or strong, we should always end up with a ketone, okay? Because it's, in the middle. It cannot, there are mechanisms to further oxidize a ketone into becoming a carboxylic acid, but for now, this is as far as we're going to go. So all of this is very important for your next upcoming quiz as well as your exam. All right. So there's only one caveat to all of this, and that is MnO2. And sorry, I know that's not a great color. So MnO2 only works with resonance. Okay. Um, so I'll show this with a primary alcohol and a secondary alcohol. Okay. So primary alcohols, let's assume you have a benzene ring. Okay. And then let's say we have a primary alcohol, which is what we're trying to get. And then let me actually try to zoom in a little bit too, so it's easier to see. All right, so we can either have a benzoic alcohol or we can have an allylic alcohol, which looks like this, I believe. One, two, one, two. Yeah, it should look like this. I was just making sure I have enough carbons. Okay. And of course, secondary is I'm gonna draw out the exact same thing, but I'm gonna make it into a secondary alcohol. Okay. So if we have alcohols that are allylic or benzoic, then and we are using MnO2, we can oxidize it just how like we're doing right here. Okay. But the only caveat, again, another side caveat is it's a weak oxidizing agent. Okay. So with that in mind, the all of them. So for the first one, benzoic, it's going to turn into an aldehyde. Such as that. And then this one is also going to turn into an aldehyde. Okay, because it's primary and it's a weak oxidizing agent and it's allylic, so MnO2 will work. Now onto the secondaries. Remember, regardless of what it is, what reagent, strong or weak, as long as it's secondary, it's going to turn into a ketone. Okay, so that should be fairly simple. Okay. So you might have noticed or questioned why we're only doing primary and secondary and not tertiary. And I'll show you exactly why. Let's say we have a tertiary alcohol and we want to oxidize it. Regardless of strong or weak, we cannot turn that OH into a double bond, into a carbonyl. Because this carbon will now have too many bonds, right? It will have 5 bonds, and that's one of the biggest mistakes or irregular things in organic chemistry. So I'll subtitle this "Why We Don't Use Tertiary." All right, so hopefully that kind of makes sense on oxidation of alcohols. to go from an alcohol to a ketone or an aldehyde. And of course, if it's a strong oxidizing agent, it can even go to a carboxylic acid. And then know the differences between the strong agents and the weak agents, know the differences between primary alcohol and secondary alcohol, know the difference between the regular ones and the exception one, MnO2, and then also know and understand why we don't use tertiary alcohols. Okay. Now on to cleavages of double bonds. I should have enough room to conduct this. Okay. And I'm going to zoom in here. Okay. So cleavages of double bonds. Of course, there's cleavages of triple bonds as well, but we're going to first talk about the double bonds. So for all of these reactions, we are going to have this starting example compound, which is a cyclopentane or pentene with a methyl group attached, just like that. And then I want you to understand that there is a methyl or a carbon there and a hydrogen here. In fact, I will draw those. So this is a carbon and this is a hydrogen. Okay. So, like I said, there are 4 reactions. We have OSO2. We have KMNO4. But this one is going to be cold / dilute / basic. And then we also have another KMNO4. This one is going to be hot, concentrated, and basic, or acidic. And of course, instead of hot, they might give you like a very high temperature, or they might just give you the heat symbol, the little triangle. And then last but not least, we have ozonolysis, which should be very ingrained by now, or in the coming weeks. So of course, underneath each of these, besides OSO2, are the solvents. So for ozonolysis, you can either have dimethyl sulfide or you can have zinc. Either or works. And then within these, we also have 2 pairings. Okay. OSO2, KMNO4, cold, dilute / basic are all considered weak cleavages. And then they both create something called syn-diol. And I'll explain what that should look like after I draw this. So when we're cleaving this, these 2 reagents will not cleave it completely. They will break the double bond for sure, but they are going to add 2 alcohols in a syn fashion. And if you remember what syn means, it means cis, essentially, or same. And then because we have 2 alcohols, that's where the di is coming from. And because, these are alcohols, that's where the OL is coming from. And that should be the answer to both this reagent and this reagent. Okay. Let me see if I can draw an arrow to make it easier. I should put it underneath. Okay. So if you went over weak cleavages, obviously the last two are going to be strong cleavages. And these will actually open up the whole ring. And I'll show you guys how. So again, strong cleavages, but the difference between KMNO4 hot, concentrated, and acidic, and ozonolysis, DMS, or zinc is KMNO4 is a strong oxidizing agent, and ozonolysis is a weak oxidizing agent. So you can technically add it to this list. It's just that I don't see it as much in an alcohol setting. So let me write that down. So strong oxidizing agent, and then weak oxidizing agent. Let's see if I can make that tinier. Okay. All right. So there's a lot to unpack in this, and so don't get confused by all the little things I talked about. So let me finish drawing it, and then I'll review everything I just talked about in cleavages. So again, like I said, the whole thing is going to break open, and you are going to add oxygens at both sides of the double bond, and then instead of a hydrogen, you are now oxidizing it to a aldehyde. Sorry, alcohol. Sorry, carboxylic acid. My bad. And then for ozonolysis, you're going to have the exact same thing at the top, at least, where it's a ketone. And that's why I wanted you guys to pay attention to the carbon versus hydrogen, because if these were both hydrogens, then these would be both carboxylic acids. If these were both carbons, then these would also be both ketones. Okay? So again, the top part is a ketone, and then the bottom part, instead of being a carboxylic acid, and I want you guys to think about this for a second. If a strong oxidizing agent will create a carboxylic acid, and what would a weak oxidizing agent create right here? Okay, if you guessed aldehyde, you are correct, and you are well on your way to get an A. All right, so I'm going to quickly refresh just this part, and then I'll move on. So we have 4 cleavages, 4 reagents, reactions, 2 of each kind. We have weak cleavages and strong cleavages. These are the reagents for weak cleavages: OSO2, KMNO4, and with cold dilute basic conditions. And it doesn't have to be all 3. It will most likely just say 1. If you see that, and wherever the double bond is, it will break that double bond, and it will add 2 alcohols in a syn addition fashion. Now onto the strong cleavages. this time it will cleave the double bond, like split open, as you see right here, and then it will add 2 oxygens on both sides of the broken double bond, and then it will further oxidize depending on if needed, depending on what the thing is, the reagent. And because KMNO4 is a strong oxidizing agent, it will turn into a carboxylic acid, and ozonolysis is not a strong oxidizing agent. It can only do aldehyde. All right. All right, so hopefully that should help a little bit with your studying of chapter 18, aldehydes and ketones. Of course, there's a lot more. So give me 1 second before we move on. Okay, actually, I think I'm gonna actually stop right here. I think this is a good stopping point for this week. So make sure you're studying this material throughout this week in your lectures and paying attention to all the reactions. And then during spring break, of course, review these, please, and then continue learning about chapter 18 and chapter 19. It looks like the winter storm kind of pushed back everything by a week. So I believe you should still looks like you might not even do chapter 19, which is amines. I just realized. So you'll actually head into enols and enolates, which is chapter 22. So they're kind of going back and forth a little bit, which is fine. But yeah, just make sure you're paying attention to lecture and review those missed lectures, or try to catch up over spring break. And then after spring break, that following Monday, I'll catch you guys up. I'll give you guys a quick refresher on everything that we learned this week, and then talk about chapter 22 as well. So yeah, if you guys have any questions, like I said, please feel free to come to these weekly reviews, as well as email me, find me in Peer Tutoring Lab, or if you want, you can write it in the comments. All right, so that's it for this week. I will see you guys after spring break. I hope you guys have a well-rested break. Bye.